Hey everybody! In today's tutorial, I'm going to show you how to build a 2-column responsive layout using Flexbox. By the end of this video, you'll know how to build this simple responsive layout. It's 2 columns on desktop, and as the viewport decreases, it stacks to 1 column for tablet and mobile. Sound good? Let's get into it. Let's start building this layout in our code editor. I'm using VS Code as my editor, and I'm also using an extension called the Live Sass extension, which you can see down here. It's watching my Sass file, and it's going to compile it into this CSS file in my dist folder. In addition to that, it's also running a local server, so I can load the actual web page in my browser at localhost port 5500. Okay, so with Flexbox, you need to have a parent element, and you also need to have some child elements in that parent. So in our index.html file, let's create a parent element. I'm going to use the main tag, and I'm also going to add a class of flex-container. I'm using some Emmet shortcuts here to make writing the markup a little quicker. So this will be the parent element in the main tag, and in that main tag, I'm going to create our child element. So the first one's going to be the main content, and I'm going to use the section tag for that, and I'll give it a class of main-content. And then I'm going to create the sidebar in an aside tag and give it a class of sidebar. Now you could also use divs for all these if you wanted to, but I try to use semantic HTML whenever possible. Okay, now in each of our elements, let's also add some text so we can sort of know which is which, and it just makes it look more real. So in the main content tag, I'm going to add an H2, and I'll write some text just saying main content. Do the same thing down in the sidebar. We'll just say sidebar. And then I also want to add some filler text. So I'm going to create a paragraph tag. In that paragraph tag, I'm just going to add some lorem ipsum placeholder text. And I'm using the shortcut lorem, and let's just say 50 words for that. And then we'll do the same thing down in the sidebar. P. Then we'll go lorem 50. Okay, so now we have our 2 elements here, and we have the filler text. So now that we have our HTML markup all set, let's go into our styles. So in our style.scss file, you can see here that I just have some boilerplate styles that I always use. We have some global styles for the HTML and the body elements, and I also have some preset backgrounds using Sass variables, as well as a little linear gradient just to make the content look kind of nice. And if you're curious, I do have all this code in a code pen, which is linked down in the description below. So let's add our Flexbox styles. So going down to the bottom of our Sass file here, first I'm going to create a selector for the parent flex element. So that's the class flex-container. And for now, all I want to do is turn on Flexbox. So I'm just going to write display flex. And we will be adding some more properties in a little bit. But the cool thing about Flexbox is that just adding this display flex is going to make the child elements display side by side in a Flexbox looking layout. So let's look at our website now. So you can see here we have our main flex container, and we have the main content as well as the sidebar, and they are side by side. Let's actually go back and add some background colors to these child elements. So I'm going to use the helper classes that I have in my Sass file, and I'm going to make the main content blue and the sidebar green. So we'll save that and then go back to our website. So now we have the main content in blue, sidebar in green. And again, the only thing that we had added here was display flex on the parent element. So if we toggle that off, it will revert back to display block and stack the elements one on top of the other. But because we just added display flex, by default, the browser is going to evenly divide the space between the 2 flex child elements in order to fit them all on one row as much as possible. Now for our 2-column layout, we do want something a little bit different. We want a little more control over the widths of the flex child elements. Specifically, what I want is I want the sidebar to be 300 pixels wide, and then the main content to take up, the rest of the available space. And we can do this by adding some more Flexbox styles to our child elements. Now going back into our style.scss file, let's add a selector for main content and also for sidebar. Now, we're going to add some flex properties to the flex child element. So to start off, we'll say flex of 1, and we're going to do that for both the main content and the sidebar. Now, this isn't going to add that 300 pixel width that I wanted for the sidebar, but for now, we just want to kind of explore how the flex property works. So let's go back into our browser. Now, we can see that the layout looks kind of the same as it did before. And the reason for this is that if you don't explicitly set a flex property on the child elements, it's just going to default to flex of 1 and, evenly divide the space between the two flex children elements. In Firefox, they have some really awesome tools in their code inspector here. So if we select the flex parent element and then go to the layout tab here, it's going to show us some Flexbox related information. So first, this is telling us a flex container, or the flex parent is the element having the flex-container class, and it has two flex child items, the main content and the sidebar element. In addition, we have this toggle on the right side here. Now, if we turn this on, it's kind of thin, but it added some lines around the flex elements. So you can kind of see, where the boundaries are, which can be pretty helpful. And if we click on one of the child elements, let's click on the main content, it kind of tells you some more information about the width of the element and how that was calculated. We're going to get into this a little bit more later, but for now it just tells us, the final size is 472 pixels for the main content and about the same for the sidebar. This is an awesome tool. I use it all the time when I'm building websites, and it's one reason why I like using Firefox as my default browser. All right, let's take a closer look at that flex property. So if you click on the main content element in the inspector and then select the rules tab, it's going to show you a rule of flex of 1. Now, the flex property itself is actually a shorthand property. And if you click on this arrow here, you can expand it. And it tells you that the flex property is made up of 3 different properties: flex grow, flex shrink, and flex basis. So what do these all mean? Well, the last property, flex basis, is the default or the initial size of a flex child item. So what this means is it's 0%, meaning the main content flex item has an initial width of 0% or 0 pixels. Now, that doesn't really make a lot of sense by itself, right? Why would you want to set the width to 0? But flex basis will work intelligently with the other 2 properties, flex grow and flex shrink, in order to calculate the final size of the item itself. Now, flex grow sets what's called the flex grow factor of the item. Flex grow can be a number of 0 or greater with a default value of 1. If you set flex grow to 0, it basically means that the element is not going to be allowed to grow in order to fit the width of the parent container, but instead it's going to stay at the width, the initial width calculated by flex basis. Now, if you do set flex grow to 1 or greater, this is going to allow the element to grow, and it also acts as a ratio to divide up the amount of growth between all the child flex items. In our case, both the main content and sidebar elements have flex grow set to 1. So since the numbers are the same, their ratio of the amount of growth is going to be 1 to 1. So this means that they're each going to grow the same amount in order to fit the parent element. And it's why both of these elements are the same width. They're both about 512 pixels. Now, if we go back in the Firefox inspector and select the main content element, it's going to give us some information in the layout tab. So this is the Flexbox inspector. Under the flexibility section, it tells us that the item was allowed to grow to fit, and that it grew about 472 pixels up from the flex basis, which, as you remember, was set to 0. Now, one thing to remember in the Flexbox inspector is that it doesn't include padding when calculating the final size listed down here. I've set a padding of 20 pixels on all sides to both the flex child elements, just so they look a little bit better. So this final size in the Flexbox inspector is 472, and it's going to be less than the actual size in the website, which it says is 512. So it's about a 40 pixel difference. So what happens if we decide to change the flex grow property of the main content element to 2 instead of 1? We can change this right in the browser if we go to the rules tab and we click on the flex value and change that from 1 to 2. So we can see that the widths immediately change. What's happening here is this has made the flex grow value of the main content to 2, and it's changing the ratio of the main content to sidebar growth to 2 to 1 instead of 1 to 1. So now because the main content has a flex grow value of 2 and the sidebar still has the flex grow value of 1, this is going to be different. So what happens is the main content element is going to grow twice the amount that the sidebar element is allowed to grow. We can see that the main content looks roughly double the width of the sidebar. However, it's not exact, and the sidebar is about 354 pixels. The main content is 669 pixels, which is not quite double. The reason for this is because Flexbox will calculate flex growth relative to the default width or flex basis of each item. So even though both elements have a flex basis of 0, their true minimum width is not 0, but it's actually going to be based on the content in them, because Flexbox is always going to size to fit the content in the flex item itself. In our example, the minimum size of the elements, both the main content and sidebar elements, the minimum size is going to be the width of the longest word in the text, because it can't get narrower than what that word is, right? So if we decide to set both items to flex 0, so let's go ahead and do that now. Main content flex 0. See, that changed some stuff, and sidebar flex of 0 as well. So now both of these items have been compressed to as narrow as possible while still fitting the content in the item itself. So for the main content element, that longest word that it has to fit to is the word content. In the sidebar, it is the word sidebar. All right, let's reload the page in order to reset the styles back to what we had before. Now let's take a look at the next property, flex shrink. So if we go back to the main content and expand the flex property, flex shrink is set to 1, and that's the same for both main content and the sidebar. So the flex shrink property is similar to flex grow, but instead of allowing the flex items to grow to fit the parent's width, flex shrink allows them to shrink in order to fit the parent's width, if by default the children would have a width that's greater, a total width that's greater than the parent's width. And we can do this by basically limiting the width of the parent. So what we're going to do is in the flex container, we're just going to set a hard-coded width of 600 pixels. Okay, so now you can see that the child items have now shrunk to fit because they have flex shrink set to 1. So what we want to do now is we want to basically force these child items to have a total width of greater than 600 pixels just to see what that looks like. So in the main content, we're going to set flex of 0, so no growing allowed, 0, no shrinking allowed, and set it at 400 pixels. So now the main content has grown to 400 pixels wide. We'll do the same thing for the sidebar. So flex 0, 0, 400. So now you can see they're both 400 pixels wide. And if we hover over the parent flex property, we can see that they are basically overflowing the parent container because the parent is set at 600 pixels. And if we look in the Flexbox inspector for the main content element, in the layout tab, so this is the Flexbox inspector, it tells us that the base size and the final size are both 360 pixels. And again, this is because if we add the 20 pixels of padding on the left and the right, we get to that 400 that we have set as the flex basis. So now let's allow the flex child items to shrink to fit the parent width of 600 pixels. So we'll do this by setting both child flex items to flex of 0, 1, 400 pixels. Oops. So if we expand that, we can see flex grow is set to 0, so they're not going to grow. Flex shrink is set to 1, so they'll both be allowed to shrink, and then flex basis is 400 pixels. So since both items have the flex shrink set to the same value, 1, that means that they will both shrink by the same amount in order to fit the parent width. So now if we go to the Flexbox inspector, it says that the base size from flex basis is 360 pixels, and again, not including padding. But now we have some additional information in the flexibility section. So it says that the item shrank or decreased by 100 pixels in order to fit. So instead of the 360 pixel width, it shrank to 260 pixels. And yeah, you can still see that, which ends up being 300 pixels after you add padding on the actual website. So it's 300 pixels there. And the same thing for the sidebar. It's set to 300 pixels. Now let's play a little more with this, and let's see what happens if we give the main content element a flex shrink value of 2. And we'll keep the sidebar at flex shrink of 1. So we'll change this to 2. Now it looks like the main content element has shrunk and it's actually narrower than the sidebar element. So let's go back into our Flexbox inspector for the main content and see what it tells us. So in the inspector, it tells us that the main content element, again, it has the flex basis space size of 360, but it has shrunk 133.33 pixels. Then if we go to the sidebar, it tells us that it has shrunk 66.67 pixels. So they've both shrunk to fit that 600 pixel width of the parent. But the main content element has shrunk twice as much as the sidebar element, because 66 times 67 times 2, 66.67 times 2 is about 133. So the reason for this is because of that flex shrink of 2 on the main content element, as opposed to the flex shrink of 1 on the sidebar element. So the shrink ratio from the main content to sidebar is 2 to 1. So the main content is going to shrink double the amount as the sidebar is going to shrink. And this is what we can see here in the Flexbox element. And again, it is important to remember that the Flexbox is going to base both of the grow and the shrink amounts relative to the flex basis of each FlexChild item. Setting the main content to have a flex shrink of 2 doesn't mean that the final width of the main content is supposed to be half that of the sidebar. It only shrunk twice as much as the sidebar. So in our example, we had the flex basis of 400 pixels for both main content and sidebar, but that adds up to 800 pixels, which is greater than the 600 pixels of the parent. So we had to shrink by 200 pixels to get from 800 to 600. And that 200 pixel amount, in that 200 pixel amount of shrinking, the main content has to shrink twice as much as the sidebar. So that's why the main content shrunk 133.33 pixels, whereas the sidebar shrunk half that, which is 66.67 pixels. Okay, so now that we've gone through how to control the width of the FlexChild elements, let's create our 2-column layout that we originally wanted to. So we said earlier that we want the sidebar to be 300 pixels wide on desktop, and we want the main content to then take up the rest of the space. So let's do that in our styles. So in our code, in the sidebar selector, we're going to set that flex property to 0, 0, 300 pixels. And what this means is we are not going to allow it to grow, we're not going to allow it to shrink, and we're going to set the default width or the flex basis to 300 pixels. So this ensures that the sidebar is always going to be 300 pixels wide, no matter what. And for the main content selector, we can keep it at flex 1 so that it can be allowed to grow to fit if necessary. So we've saved that, and let's check out our website. Now in our website, we can see that the sidebar is 300 pixels wide. Yep. And the main content is taking up the rest of the space, and they're all fitting together on one row since we have Flexbox turned on. So if we take another look at the Flexbox inspector, it tells us that the sidebar has both a flex basis and a final size of 260 pixels. Adding on padding, it results in 300 pixels of total width on the website. And if we go to the main content element in the inspector, it tells us that in the flexibility section, it was set to grow, and it grew 684 pixels in order to fit the rest of the parent content. So if we change the viewport width, keep an eye on this final size down here, and it should change based on what the viewport width is, because the main content width is going to change in order to fit the full width of that parent element. So this 2-column layout is what we want on desktop, but how do we make it stack for mobile and tablet? Well, one way that we can do this is to only turn on Flexbox for desktop widths. So what this involves is going into our code, and what we're going to do is we're only going to use this display flex rule when a certain viewport width is reached. So when a viewport width of, let's say, 900 pixels is reached, then we'll turn on Flexbox. But up till that point, it's not going to be display flex. So to do that, we can add a media query. So at media, and then the criteria is going to be min width of 900 pixels, but we want to use EMs instead of pixels for better accessibility. So to get from pixels to EMs, you take the pixel width, 900, and you divide it by 16. This is because 16 pixels is your default browser width. So 900 pixels will convert to 56.25 EMs. So It's just something that I try to do to keep the website more accessible and allow users to adjust the size of the text by adjusting the zoom in their browser. So using EMs, if I can add that unit on, is what's going to allow that to happen. So now what we have going on here is in the Flex container, by default, it's going to not be Flexbox. So it's going to just be display block because that's the default. And then once we hit that 900 pixel, let's add a little comment here. Once we get that 900 pixel viewport width or 56.25 EMs, then it's going to turn on Flexbox. So let's go back into our browser and see how that looks. It looks the same, right? And that's because we are greater than 900 pixels in our browser window. So if we decrease, then we can see that at this point here, at our breakpoint, this is when it converts back to display block on the parent. And if you look down in the rules tab, as I keep increasing the viewport, you can see the point where it becomes the 2-column layout. The Flex container then has the display flex property. I hope this tutorial has helped you understand how to build a 2-column responsive layout using Flexbox. My next video is going to be about how to build this layout using CSS Grid, so stay tuned. And if you're not following me yet, don't forget to subscribe. If you like this video, give it a thumbs up. If you have any questions or feedback, leave a comment down below. And as always, thanks for watching and keep on coding.